With that, that's our last formal presentation, but we're going to kick off the question and answer session now. So I'd like to ask the 4 presenters to come up onto the stage. If you could join me up here. For what we'll do for questions, we have those in the chat online that can enter them, and we have people with laptops here that will ask them. But if you are here in person, you just come to one of the microphones, identify yourself, name and affiliation, much like for those of you that were at AAPT. Ask your question who you're directing it to, and we'll proceed that way. So you guys can come on up and we'll get started. So any questions?
Brett Stanton with the Asphalt Pavement Association of Michigan. My question's for the contractors. Storage silo time was mentioned in a couple of the presentations. So I'm just wondering if any of the contractors either monitored storage silo time during this or put any parameters in place to make sure that that was limited. And a follow-up question to that, if any of that was tracked, did you guys notice any differences, or how sensitive were the performance test results to differences in storage silo time?
I'll take a step first. Thanks, Brenton, for the question. I think just simple answer is no, because it's been a challenge, really, to track the silo time. Although, as you said, excuse me, it might have a significant factor on the performance test result, but typically during the busy season, it won't be too long for the material staying in the silo. So the silo time is really minimized. However, it varies from plant to plant and depending on the time of the year as well. But that's a great comment that we will be definitely worth looking further at and to see if we want to set a limit, say, try to minimize the time to minimize the impact, how to say. Yep. So that was my answer. Thanks.
Thank you.
We do store quite often. Perimeters, we try not to store more than one night. It's rare that we go longer than storing over more than one night if it's a rain event, but it's very rare. We did not track it that closely to see how stored material, the results versus the results made the same day. So it gives me something to look at in the future, though.
All right, thanks.
Jean-Paul Faure with Scholars. So this question is for Chen, and it's not really a question, it's comment on our discussion during the break. That's one of them, and I have 2 remarks after. So our discussion point was about the difference between the limestone and the granite on that high feet that caught my attention. And so the comment was to look at the loading curve and where it's coming from, whether the fracture energy of the slope, that will probably help understand why this difference, dig a little bit in the cause of this surprising difference. And also after that, looking at the binders, stripping compatibility, whether with granite or limestone. So I don't know if you want to elaborate on that.
Sure. The first comment about the IFIT numbers, I agree. I think what we just communicated during the break about the importance of looking at the curve rather than the parameter itself, because it may caused by the fracture energy, which is the area on the curve, or by more of the related to the stiffness, which is represented by the post-peak slope. So as John Paul mentioned, that there could be 2 significantly material behaviors by having the same FI number. And honestly, we haven't looked at that, but it's definitely worth looking further into this, and I'll dig into the data and share with you later as well.
And the second point that we didn't discuss, but the break that caught my attention also with the fact that your production mix comes out softer than your design. And to go on what the gentleman from Michigan said there, we had those issues also in some of our earlier production of high variability of high fit, depending in particular on the point of sampling. Because if you take the truck, so you just read, but if you take behind the paver, most of the time you have to cool down and read totally. And that has affected a lot our high fit numbers, to the point that for that particular DOT in Illinois, we decided to go from the truck, period. No reheating from behind the paver. So I don't know if you can elaborate maybe also on the reason why your production mix would be softer than your lab compacted specimen.
I suspect it is mostly related to the aging. I think Stacy actually mentioned in your presentation that they actually use 2 hours for the rotting test, right? And the Cantabro as well, but use 4 hours for the cracking test. And also NCAT Chapter 9-52 recommended, using shorter aging time to represent the, short-term aging through the production and also late on as well. So might be more related to aging, but I'm not sure until I got further data to look at. Yep.
Yeah, we're gonna switch, do online question, and then do kind of do 2 for 1 with the in-person question. So go ahead, Fan.
All right. We do have one question from Chris Edwards that came in during one of the Vermont presentations. His question reads, has a correlation been established between lab specimen and field specimen for the testing results? What should we expect during production in relationship to the lab results? Any panel want to take that question?
Could you speak up again, please? Because we couldn't hear that very clearly.
Oh, okay. All right, I'll repeat the question. Has any correlation been established between the lab specimen and the field specimen for the testing results?
I'll try to interpret what I think he was asking is lab mix or mixed design samples versus plant mix. And I think Ching presented some results comparing lab mixes to plant mixes from the same mix design. And you showed that a lot of cases they were softer, which indicated that the rutting numbers went up and the cracking numbers, the cracking resistance improved. I think that's what Chris was asking. If anybody would like to elaborate on that observation about lab to field differences.
Yeah, as I mentioned earlier, as far as Cantabro is concerned, design versus production, not much of a difference. And for the short-term aging, for the 4 hours, design versus production, we've definitely got better numbers through the plant. But the short-term aging was close. I mean, it wasn't far off. Now the 12-hour aging was way different, but it's about all I have on that.
All right. Chen, you got anything else to add on top of that?
Sure, I just don't want to really talk too much, I think as shown in one of my slides, they're listing the potential or talking about the potential factors during the production which can affect the performance test result between the design and the production. That actually can be tied up to a lot of factors. Such as the production variation and also the binder source and aggregate property changes as well, a lot of factors. Although the goal is always to match the production numbers with the design number, but it's really a challenge for getting to that point. So the thing that we can do is just keep collecting the data and see if there's a major trend. If not for 100% of the mix, if we can see the trend through like 60-70% of the mix, maybe we can get to know, what's really controlling that and cause a difference between that. So,
all right, thanks, Chen and Danny for the comments. The next question, assume this is, for the DOT panel members, is from Blair. what qualifications, training, and the certification program do states require for personnel that run the rutting and the cracking test for balance mix design?
So far for rutting and cracking, we don't have a requirement. The idea is that we're going to incorporate it into our mixed design courses and some of it would be the plant and field courses, mostly the plant courses, so that you can get, the things with proficiency. The problem is, until we get some precision and bias statements, it's hard to enforce how good you are at repeating the test. But yeah, I think that's coming. It's just a matter of time.
Okay, thanks. Eric, do you have anything to add?
I will agree with what Stacy just said regarding precision and bias statements overall. Currently, we don't have any requirements right now in terms of proficiency for rutting and cracking tests, but I envision at some point our regional certification program, NCAT, will take this into account. And last I checked, they have been revamping the courses over the last few years. And anyone in this room can correct me if I'm wrong on that statement, but I'm not directly involved in NCAT in general, but that's my understanding.
I'd just start by thanking everyone for their presentations and sharing your experience. Brett Williams with the National Asphalt Pavement Association. My first question, I think, Stacy, you mentioned designing asphalt mixes through the plant. And I know a lot of agencies have like multiple point mix design. So I was just curious if you could maybe share a little bit about like how, if there's variances in the mix design requirements or what the requirements are, or how that's done through the plant versus through the lab.
Honestly, I can't say a whole lot about how it's done. It's just from some conversations with folks that say that rather than doing a full lab design, they're running their designs through the plant so that even during design, I think they're able to submit information that's going to be accurate and matching what they're going to get later. But yeah, we do have requirements on, gradation bands, asphalt content, air voids, the whole 9 yards for design. But yeah, I was trying not to pry too much. But it was just some side effects of some conversations.
Okay, thank you. I have one other question that I'd ask, and this one was for Aaron. You mentioned an upcoming or a requirement on Delta TC requirements, I believe, in your presentation. And I was just curious because you had mentioned that you have polymer requirements, and I just didn't know if, because there was a presentation even this week at AAPT about how polymers can have a negative impact on Delta TC. I just didn't know if you have some thoughts or could share like what you're doing as far as that goes.
Sure. So right now we only require SBS polymers in our specifications, and as part of rolling out the Massacre PG binder grading system in Vermont, we are going to open up the possibilities regarding what modifiers will be allowed on both the high end and the low end. And basically for Delta TC, I don't have any thoughts specifically regarding SBS polymers and Delta TC, but what I can say is that we are going to have a -5 degrees Celsius with 40-hour aging involved. Does that answer your question?
I think so.
Okay.
Swati with Asphalt Testing Services and Engineering. Great presentations, everyone. I think my question is more towards the DOTs. So how likely are you to consider long-term binder performance when you're developing this whole framework for balanced mix design? And I also want to hear what the contractors think about that in terms of figuring out their binder supply when getting your balanced mix design together.
Having a hard time.
We're having a hard time hearing. There's a lot of echo.
Yeah. Long-term binder performance.
Yes, how likely are you to consider long-term binder performance when you're getting the balanced mix design specs together?
Specifically looking at long-term binder performance, I don't see us doing that directly, but during the design process, currently we're requiring an overnight aging or long-term aging for test specimens. And we would expect that in the cracking test to indicate some of those aging properties. Not as far as I'm aware, none of our producers are set up to do the binder testing. I mean, we operate on COAs and BOLs from the terminals. So I wouldn't expect that unless we decide to change our approval process for binders coming in to reflect that. And I don't think that's on the table at this point.
Okay. I mean, as Chung, he had it in his presentation, binder definitely showed a difference in the IFIT values. So that my question was just stealing off of that. Thank you.
I'll also add that we're not necessarily looking at long-term binder performance either. We're starting to move towards testing the cake, if you will. So long-term aging overall of the asphalt mixture itself is more of a concern for us as an agency.
All right, we do have a few more questions from the online audience. The question asks, how do you adjust to get a balanced performing mix if you have constraints on like no wrap use or limited virgin aggregate availability from the contractor or the mix design perspective?
You have to repeat that again, I'm sorry.
Okay. I'll rephrase the question a little bit. So I think this is a question asking from a producer perspective. If the agency have a limitation on the wrap content or the recycled material content, and then given the location of where they are, they have very limited virgin aggregate choices. So what can they do to adjust their mix to get a balanced rutting resistance and cracking resistance? Does that make sense?
Well, I could take that one, or at least start it off.
Okay.
Contractor. I think it would be very difficult. It would be difficult, or it's certainly more challenging. There are a lot of constraints, binder content, ingredient, and wrap content and whatnot. The binder content, the percent binder in the mix, as I said before, can help achieve either a wetting or a cracking criteria. So if you're having an issue with a high rut numbers, reduce the binder content, that will give you lower wetting numbers, and the inverse for cracking. But there's also rejuvenators that are available that will help performance, as well as the type of binder that can help with the performance. But certainly, if there's a lot of criteria, if there's a lot of different restraints on the mix overall, that's going to limit your options as far as what you'll be able to do in order to meet that.
I think during the presentations by the three contractors representatives, I think we all touch upon this here and there, and there are always challenges and constraints as regards to the mixed design adjustment. And one of the things that at least we learned from this pilot study is if you have the option on the liquid supply market that you can choose from, maybe try different liquid source and see how it goes. It may not really fit for a specific location, but maybe work for another location. So maybe that's one of the ways that you can look at, one of the easiest way, I'd say. But if you don't have that option, and you have other, constraints like the aggregate source, you don't want to adjust the AC content and many others, perhaps you will have to reconsider the way that you design the mix, the aggregate structure as a whole. So just try, if you are using the fine gradation, just try the coarse one and see how it goes. Although it could be a challenge during the laydown and the compaction, but that will be a different story. But at least just try something and see if it can work out for you. So just try to do your work and see what works best for you in your situation. Thanks.
Yeah, as we spoke on, I think, there's a lot of variant factors that influence ideal values. Having a great relationship with your aggregate supplier and running tests during season on your aggregates is very, very crucial. It's amazing just the aggregate change in GSPs and particle shape that take place during the season. And staying on top of that, all those things are going to affect the outcome of your ideals, especially, here I'm talking about high wrap, and, that's a challenge, but it can't be done. You got to know where your wrap's coming from. You got to know what's in it. You got to have some space to isolate different types of wrap. You got to run tests before you put it in your mix. It's very, very involved. You got to be proactive rather than waiting for a change to happen and go chase after it.
Next question is regarding benchmarking. As a few of the panel members discussed the importance of doing the benchmarking. So this question is asking, what exactly does benchmarking the mix means? Since this is probably someone that does not have too much experience about balanced mix design, so just want to get some, get started with what benchmarking means.
What we consider benchmarking is taking whatever mixes we're producing right now and testing them as if they're a BMD and find out where we fall. You can't move your mixes forward, whether you're industry or on the VDOT side to write the specs until you know where you stand now, so that you know what needs to be improved and what direction you need to go. So that's what we've been doing.
I'll second that. You need to know where you are before you can go anywhere. So understanding your mixes and just where, if you took your everyday mix, where does that lead you on a performance scale? That's your starting point. That's your benchmark.
I'll just add to that definition that Stacy gave. I think that's quite consistent with what I think most people consider benchmarking is understanding what your current mixes are in terms of the performance test, whatever test that you're going to use. I'll add to that one thing is that you probably want to do benchmarking on both lab prepared mix, as well as plant produced mix, because there can be differences, as we've already kind of discussed a little bit. So two parts, I think, to doing benchmarking: lab mix, lab prepared mixes, and plant produced mixes.
So the next question is specifically asking the New Jersey presentations. How long do you allow for mix design verification process, or is there a time limit? I think this is something that Stevenson brought up, but I know he's not here with us. I don't know if that's something, Kai, you will be able to provide some response.
That's a good question. I can look into that and email that the questionnaire for that.
Okay.
For the exact time period that it takes. My understanding of the question is what is the turnaround time for testing?
No, how long do you allow for mix design verification process?
Okay. Yeah, I'll defer to Stevenson on that one.
Okay. Well, if you have the answers, send us the comments in the chat box, and we'll announce to the group. All right. The next question is very interesting. That's a question many of us have, including myself. Which performance test is strongly correlated with field performance?
We wish we knew.
Yeah.
It depends on where you are in the country. Let's put it that way.
Randy, you want to talk a little bit about what we found out from the cracking group in terms of the lab versus field correlation?
Yeah, I'm sorry. I was reading some of the other questions online, so I'm probably, the question was about lab to field performance.
What is a basic cracking test?
Oh, well, That has been, the holy grail question for 5 years or as long as we've been looking at different tests. I think Napa actually put together recently a nice little publication that says, these are important things to think about in selecting what test you want to use for your BMD. And the number one thing is correlation to field performance. That's actually the hardest thing to figure out. And that's one of the reasons that we got into what we call the cracking group experiment back in 2015. I'll come back to that in just a second. But first of all, there are other important considerations that the speakers already brought up this afternoon that are also very important from the implementation point of view or implementability point of view. Turnaround time, variability, ability to sensitivity to the mix effects that we know have an impact on performance. All those kind of things are important factors in making that decision. So going back to the lab to field correlation, we wish we had a lot of field performance data for all of the mixes that we've started testing, but it takes a long time to kind of build that information. So we put together an experiment in 2015 to build test sections and evaluate test sections at the NCAT test track. We just completed that work earlier this year, where we looked at field performance over a 6-year period. And we had in that experiment mixes ranging from good cracking resistance to fairly poor cracking resistance. And we ran a number of different tests. Most of the BMD tests that have been talked about today and earlier this week at the AAPT meeting. So we looked at, I think, six or seven different cracking tests. Most of them had a pretty good R-squared or correlation between lab results and field performance. The best relationships were on mixes that were aged. Aging is a very important factor in cracking resistance. Okay, so we included that as part of the study that we did. So rather than trying to spend 20 minutes talking about that experiment, what I'd like to do is just reference that report that's in the resources. Again, that's that QR code that's on the program or the agenda. Look for that NCAT cracking group report. And basically it lays out for you all those correlations. So again, the long and short of the story is most of those tests have pretty good correlations to field performance. So that checks the number one box, in our decision-making tools. So you can go to those other things like simplicity, cost, repeatability, and let those kind of be the factors, the other factors that really drive that decision.
Richard Willis with the National Asphalt Pavement Association. This will probably be more directed to Aaron and Stacy. Most of the states that we're talking to about BMD are very much in that, if you look at the 4 different types of BMD or categories, they're very much in the phase A, where they're looking at controlling volumetrics and controlling performance, which takes a target that was that big and now makes it that big for contractors. And we're more interested probably in that type D BMD, because it allows us to look at what's available in the different part and what is around us and try to make the best mix using locally available sources or sources that maybe are under a vertically integrated company's control. How can industry work with states to move them out of that type A BMD kind of down the scale to where there's a little bit more opportunity to innovate and use some different types of materials that maybe we didn't always use in the past to try to really harness the potential from these different materials? And Stacy is a state that's looking at A and kind of D as well. I'd be interested to hear why y'all kind of went with that approach, or what what made you comfortable with saying, you know what, maybe we will dabble a little bit in this other area?
Well, I mean, the reality is if you stick with that A mix, you are taking that target and just shrinking it. If we want to look for, from a state perspective, we've got to look at economics and competition. We're a low bid state. If we, the more we shrink that target, the more expensive our mixes get. If we can say, well, this part of the target can go free, we're going to aim over here, but everything else you can do your way. We've got more opportunities for innovation. We've got more opportunities for competition, better economics coming out of it. It's a mutually beneficial thing. In getting there though, yeah, I mean, I think there's that natural tension between, I guess you would call it, the DOT and the industry of, can you trust each other? For some, but the idea is that the DOT is here for the public good, but the industry is here to make money. I mean, that's the way we are. And so getting over that to really realize that all of this is in both best interests. If we keep doing things the same way we've been doing them, we're going to get the same results we've been getting. And maybe this makes me optimist, but I think it's in all of our best interests to look outside the box and open our eyes and be willing to at least try things. Maybe we try something, it doesn't work, so we back off some. But quite frankly, I feel like from a DOT point, and this is me in research speaking, I can't say for the DOT point, I don't see that industry doesn't want this to succeed. So I feel when we've gone into these projects, Danny and I've talked a lot, we both want this to work. So we're both going to bring the A game and try to make it the best we can. If a company wants to stay in business and do better, they're going to need to bring their A game. And it needs to become an expectation and just a way we do business. Unfortunately, that still falls under that low bid system, but we're hoping that we can find other ways to incentivize that A game. But I think it boils down to, in a lot of ways, just getting experience doing this. I mean, if we said we were going to completely throw out the box on anything, whether it's mixed design or, looking at concrete, looking at steel, everybody would freak out. We take it in baby steps. So we've been doing limited trials. The more limited trials go well, the more tonnage we put out, people become convinced that yes, we can do it successfully, and we can get a better product out of it. And it's just kind of that shift in mindset. And it has helped, in our agency and in our industry, we have really good relationships. I think probably the best they've been in 20 years between the agency and the industry. And so, we're all moving kind of in that same direction of collaboration and cooperation.
I unfortunately cannot come up with a better answer than what Stacy just said. But from my perspective, I think the relationship between the paving producers and contractors and the state DOTs is getting better and better each year.
In follow-up to Richard's question, a lot of states do things like, have done things to get more binder in their mixes, like regress air voids and change VMA specs and that type of thing. And when you do that, you're messing with volumetrics, right? You're shifting away from what's in the, it's historically been used. So you're sort of forced to do that anyways. So I want to, I guess, reiterate Richard's question. In messing with some of this stuff, some work that we've done is been designing mixes at lower air void levels. You've got higher effective asphalt content when you actually look at the effective binder content, and you're not getting any issues with your wheel tracking test results, for example, but getting very good cracking test results. And if durability is what we're after, I think we should be given that, due consideration. And, I'm old, I'm an engineer. I don't want to give anything up either, I'm not going to tell you to look at volumetrics. But I think that really hanging on to volumetrics and not allowing designers to step away from them to get better performance is really sort of short-sighted on the industry. It's not everybody's part. So maybe you don't want to respond to that. It's just food for thought.
Going also to Richard's question, the one biggest part of this is that you have to have real faith in those tests. And that's, I'd say, where the real lack of faith is in the test. What happens, when I put something in, and I'll give you the perfect example of that, because we've all had experiences with it. We thought we had a performance-based binder specification, right? These tests are going to tell us everything we wanted to know. And then we found out that, well, no, they really didn't. I could put a little of this and a little of that. The tests looked great, but things went bad. And so that's, I think, probably part of that learning curve. And that's why Stacy says, well, we do trials and we look at this and we look at that, because everything we do is really an estimation, a model. It's not the real world. And so if we try new things, well, is this modeling that we're doing, whether it's with a test or something else, really reflect performance in the real world under traffic? So you got to take those steps, but, and that's exactly what's happening today. And I think that, that's great with some of the trials you do. And as you get more faith in the test, you try more things in the test to see what you look at. And I think that, again, with, if you get NCAT with the track and some of the stuff they're doing, they expand on that knowledge. You get each state does something different. Now, I can't transfer maybe what happens in Vermont to Virginia, even though they both start with a V, I guess, but you can't, it doesn't work that way. But at least that gives you something to say that when someone else tries something different, if it at least doesn't fail, it may not work for me, but it didn't fail for them. So it's something I can try. And I think that's going to be the key part, is to get that knowledge out to everybody.
And I'm gonna take the opportunity of standing up here to just share a couple perspectives that we heard from some of the case studies of other agencies out there as well on exactly your question, Richard, Adam, and John, is that a lot of agencies we talked to did want to start with kind of the approach A of narrowing that target, and then wanted to see what wasn't necessary anymore, maybe from their specification and take away there. We did get some thoughts from some of those agencies, though, that, volumetrics may still have a place in determining whatever the aim is, not a right voids content for every mixed design, but seeing that it was consistent. It's a tool to potentially use there, but considering that as well. And then the last perspective that came out from those case studies that I'd share, especially what you just mentioned, John, is that, again, implementation is going to have to be iterative. It's always going to have to be, so we don't fall into what you just mentioned about the PG binder spec of, continually checking back against performance with whatever tests you have to ensure that relationship is still there. It may not be, okay, we have that relationship, it's done, we don't have to worry about this anymore, we're implemented. It's more likely to be something that's iterative that these agencies said they're going to have keep an eye on. So just something I want to share. Go ahead, Randy.
Yeah, I'm just going to, one of the questions that has come up, and maybe I'm repeating it, but I've heard this question, not just this afternoon, but before, is how is the criteria set for these performance tests? What is the lab to field correlation that helps us establish what the number, the criteria should be? And I'm not going to give you the answer because that's part of the discussion tomorrow for the breakout sessions, is for us to really debate that issue. Some of the ideas I think have been presented this afternoon. There are other ways to do that. And it really probably needs to be discussed more about how we should select criteria for our tests. And it takes time. That's an opinion, but that's not the answer. Okay. Derek, I'll turn it back over to you to offer a few closing comments, including the comment about the
Cups. Yeah. So first of all, I want to thank our presenters and our panel for sharing their experience and everything. It's really helpful for everyone. So let's give them a round of applause.